So, you're starting your second ochem lab, the extraction of trimyristin from nutmeg? Well, welcome to the wild world of ochem. You're in for a ride. Here we have funky smelling liquids, suspicious white powders, questionable yields, 20-step processes with hour-long waiting times. While all of it may seem a little overwhelming, don't worry. We got you. We're gonna walk you through this first real ochem lab and the techniques you'll need from now until the end of the second semester. We're going to cover how to set up the glassware, how to weigh product, recrystallization, vacuum filtration, melting point, and how to do your pre and post lab. So let's start with the lab. So what's the goal of this lab? To extract trimyristin from nutmeg using TPME, to isolate using vacuum filtration, to purify using recrystallization, and to confirm the purity by finding the melting point and comparing that with the known product melting point. Whew, that's a lot. But let's go over setup and techniques real quick. First, you want to get out your glassware, your round bottom flask, your air condenser. Then pull out from your plastic tub an aluminum block and a thermometer. Also get a hot plate. To measure the temperature, make sure you stick your thermometer into the hole. Once you fill your flask with stuff and you're ready to cook, screw on the air condenser and make sure the O-ring's on to seal it properly. Clamp it onto your stand, settle it on the aluminum block, and turn that thing on. Remember, glass and aluminum look the same when it's hot, so be careful, little bro. Since you're going to be weighing stuff a ton, here are some general tips. So you're gonna weigh using a balance. You put in your watch glass, beaker, weighing paper, weigh boat, or whatever in. You close the door, let it tear, and then start adding your powder in slowly. My personal pet peeve is when people leave the door open when you're weighing, cause the air will affect the weight and it'll keep fluctuating. This scale is more sensitive than your dad's ears when you're trying to play video games past bedtime on a weeknight. I see it ticking up and down, and it's just... Close the door, please. Thank you. So you're gonna need to weigh both your crude and recrystallized product, and there are two general ways of doing this. One is by tearing the weight of the empty container and then storing that on the balance as you scurry away and put in your product and then reweigh it, but that's low-key kind of risky and bothersome because bro's taking up an entire scale and you have no idea who's gonna mess with it when you're not looking. So it's easier to find your container weight, record it, reweigh with your product on the watch glass, and then do the simple subtracting. Oh man, this thing is gonna get covered a billion times in future videos, but we got assigned to the first experiment where it's used, so automatic first tips, I guess. So we're gonna set up your vacuum filter first. We're gonna put on that rubber gasket onto the vacuum filter and plug it nice and tight into the flask. Then get your filter paper. He's special paper, don't use regular paper, and then put him on the filter. Then stick the vacuum tube thing on the armhole thing, nice and snug, and then turn on the vacuum. It's loud, and it'll sound like someone looped your dad snoring into the drumline for some EDM remix. Yeah, pour in a little solvent to make a seal, and then start pouring in your product while using solvent to rinse off any product left behind. Oh, this is wet nutmeg, by the way. This is not what your product is gonna look like, because we just can't be bothered to do this entire experiment again. Purgatory isn't something we want to go back to, kids. Just once is enough. Also, dog, if you're isolating your recrystallized product, please make sure it's cold. This vacuum is strong and it'll suck your fluids out faster than an overcooked meatloaf. So, if your product is warm and redissolves into the solvent or just hasn't crystallized enough, say bye-bye to a pretty yield percentage. This is also going to be pretty common for future experiments, so you're going to want to know this too. You dissolve the crude in boiling hot solvent, you cool it down slowly to form pure crystals, and then vacuum filter out the excess solvent and whatever gunk is left over. Sometimes the procedure might tell you to put your crude on the hot plate to dry it more fully, but I learned the hard way never to put your crude on without having at least some solvent in there. I legit went from drying the crude to finding its melting temp. But in general, you boil your solvent and then use a pasture pipette to dissolve your crude with a minimum amount of boiling solvent while swirling. And then you take it off the heat once it's dissolved, you cool it to room temperature, and then put it in an ice bath to recrystallize. Recrystallizing it should be slow. If it's too fast, it'll catch impurities. And if you don't see anything forming after a few minutes, you gotta scratch it or something to get it started. Don't ask me why. Once it's recrystallized, it'll be back to our familiar friend, the vacuum filter. Yippee! After all that's said and done, we want to find the melting point. You're gonna get an itty bitty glass tube and stick some of that recrystallized product in there and tap it rapidly to get it down to the bottom. Then you stick it into the machine, wait for it to melt, and record the temperature where it begins and finishes melting. You can see whether your experiment actually got you your desired product by comparing it with the known melting temp for a pure product. Impurities will lower your melting temp and give it a wider range, so fingers crossed for pretty numbers. Well, that is it for the lab portion. For your pre-labs, most of the stuff should be covered in the syllabus/lab instructions, but there are a couple things I want to touch on. First up, when it asks for reaction scheme versus mechanism, what is that? Well, reaction schemes are just a summary of the chemical reaction with the reactants and products and the solvent/reagents over the arrow. You're familiar with this stuff, right? Right. But mechanisms are about the electron flow and how those movements dictate the chemical reaction, and there's like 200 of these that you might need to memorize, but like, that's a future you problem. Don't worry about that for now. But you know what is more pressing right now? Reagent tables. They're used to determine the amount of each reactant needed. You remember stoichiometry and molar conversions and all that? Yeah, they're back. Did you really think you escaped? You may think you're done with Gen Chem, but Gen Chem is not done with you. What you're gonna do is list out each reactant actively participating in the reaction. You find their molecular weight, the number of grams you're using, and from there, find the number of millimoles for each thing. Here's the equation, cause not gonna lie, when I did this lab, I kind of forgot how to do it, so. The reactant with the smaller number of millimoles is the limiting reagent, and typically it's never the solvent. You're going to want to hold on to this number for your post-lab to find the theoretical yield, since in ochem there is usually a 1-to-1 stoichiometric ratio of reactant and product, so that's nice. Just do it. Chemicals do things to you. The more you mess around, the more you find out, and that is why we find out from the people who have already messed around for us. Just use the MSDS, little bro. It's relatively straightforward, but let's go over the icky math real quick. These are probably also gonna get covered a billion million times, but oh well. Remember that whole reagent table thing? Yeah, it's kind of similar, but just do it in reverse. Take the number of millimoles of theoretical product and convert it to grams, keeping in mind there's a 1-to-1 stoichiometric ratio of reactant to product. Here's the equation. Keep in mind, it's called theoretical yield for a reason. Whatever number you get in here, that is 100% of what you could possibly ever get. Because we live in an imperfect world, loss will always happen. Things such as transfer loss and incomplete reaction, or maybe a certain lab mate accidentally submerges your recrystallizing product in the ice bath. I don't know! Anything could happen! Which is why we can measure how much y'all messed up with your percent yield! These calculations are super simple. Grams of isolated product divided by grams of theoretical product times 100. If you get more than 70%, yay, good job! 40%, okay. 3%, you goofed. 105%, you really done goofed. Check your calculations. Negative percent? Bro, who let you cook? Allegedly, it's happened before though. One classmate's product with a beaker weighed less than the beaker when it was empty, so that's definitely a skill issue with the weighing, womp womp. Anyway, this should cover all the big important stuff for this lab and for parts of the lab in the future. Hopefully this was helpful, or at least somewhat entertaining. Okay, love you, bye.